We proceed the chapter laws of motion, and we are doing questions numericals of exercise, laws of motion. Let us see question number 5.5. Question number 5.5. That is a constant retarding force of 50 Newton. There is a retarding force. Retarding force is represented by minus. Minus sign shows that force is retarding. So a constant retarding force minus 50 Newton. Minus 50 Newton. Force is minus 50 Newton. Is applied on a body of mass 20 kg. This retarding force is applied on a body of mass 20 kg. There is a body of mass 20 kg and the retarding force minus 50 Newton. Retarding force 50 Newton is applied to a body of mass 20 kg moving initially with a speed of 15 meter per second. The body is moving initially with a speed of 15 meter per second. We have given the initial velocity u equals to 15 meter per second. And since the force is retarding, means this force disturbs the motion of the body. So after certain time, the body comes to rest. And when it comes to rest, then the final velocity will be 0. V equals to 0. So initially with a speed of 15 meters per second, how long does the body take to stop? How long does the body take to stop? So we have to find the time. After how much time the body will stop? So firstly we'll have to calculate acceleration of the body. So we know from Newton's second law, F equals to m into a. F equals to m into a and a equals to F by m. The force is retarding, which is minus 50 Newton, and mass is 20 kg. So the acceleration is minus 5 by 2 meter per second square. So minus 5 by 2 meter per second square. Acceleration acts on the particle when a retarding force 50 Newton is applied on the particle. Minus sign shows that the force is retarding. Now we have to calculate time. So we use the first formula, first law, V equals to U plus AT, first equation of the motion. V equals to U plus AT. V is the final velocity, it is 0. Initial velocity is given 15. Acceleration we have calculated minus 5 by 2 and time is t. So it becomes minus 15 equals to minus 5 by 2t. Minus gets cancelled and 30 equals to 5t and the value of time t is 30 by 5 means 6 seconds. So after time 6 seconds, the body will stop when a retarding force is applied. So when a retarding force of 50 Newton is applied on a body of mass 20 kg and the body is moving with a speed of 15 meter per second, then how much time it will take to come to rest? And when the body comes to rest, then the final velocity v will be 0. So firstly we calculate acceleration. Acceleration equals to force upon mass. Then we use the formula v equals to u plus at and we calculated the time taken. The next question is 5.6. Question number 5.6. A constant force acting on a body of mass 3 kg. A constant force acting on a body of mass 3 kg. Mass of the body is 3 kg. And there is a constant force acting on a body. Changes its speed from 2 meter per second to 3.5 meter per second. Initially, its speed was, initial speed u is 2 meter per second. And when a constant force is applied, its speed gets changes. Means it becomes final velocity, which is 3.5 meter per second. So mass is given 3 kg, initial speed is given 2 meter per second, final speed 3.5 meter per second, and it is mentioned that a constant force acting on a body of mass 3 kg, then speed from 2 meter per second to 3.5 meter per second in time 25 seconds. We have given the time. Constant force acting on the body for time t equals to 25 seconds. A constant force acts on a body for time t equals to 25 seconds, and the force remains unchanged. What is the magnitude and direction of the force? We have to calculate the magnitude and direction of the force. Calculate the magnitude and direction of the force. Find the magnitude and direction of the force. Means force we have to calculate in magnitude and direction. So to calculate the force, we will have to use the formula force equals to mass into acceleration, and mass is given. It means from the given information, we will have to calculate the acceleration. So v is given, u is given, and time is given. So again we use the first equation, v equals to u plus at. Final velocity 3.5, initial velocity 2, a we have to calculate, and time is given 25 seconds. So 2 will goes on left side. So 3.5 minus 2, 1.5 equals to 25a. And the value of a, 1.5 upon 25. And remove the decimal. So 3 into 5, 15 and 15. So it gives 3 by 50 meter per second square. This is the acceleration produced on a body due to the constant force applied on the body. And now we find the force acting on the body. So force equals to mass into acceleration. The value of mass is 3 and acceleration is 3 by 50. So 9 by 50. 9 by 50 Newton is the force acting on a body. 9 by 50 Newton. It is 9 by 50 Newton. Now we have to calculate. Already we have calculated the force. 9 by 50 is also written as 0.06. 0.06 Newton acts on a body. Acts a force 0.06 Newton acts on a body. Fifty 3 by 50 and 9 divided by 15. This is 0.06. 0.18 Newton. 0.18 Newton. Now this is the magnitude of the force. Also we have to calculate the direction of the force. So since as the applied force increases the speed of the body, as the applied force increases the speed of the body, because its initial speed was 2 meters per second and the final speed is 3.5 meters per second. So the direction of the force must be in the direction of the motion of the body. So we write about direction as the applied force, as the applied force increases the speed of a body, as the applied force increases the speed of the body, hence the direction of force, hence the direction of force is in the direction of motion of the body, is in the direction of motion of the body. So the force applied in the direction of motion of the body, because the speed goes on increasing. It means the force, the direction of the force is along the direction of the motion of the particle. Now question number 5.7. Question number 5.7. It is given that a body of mass 5 kg is acted upon. A body of mass 5 kg is acted upon by two perpendicular forces. A body of mass 5 kg. There is a body of mass 5 kg acted by two perpendicular forces, F1 and F2. And the mass of the body is given, and a body of mass 5 kg. A body of mass 5 kg is acted upon by two perpendicular forces, 8 Newton and 6 Newton. The mass of the body is given 5 kg. This is 5 kg mass, which is acted upon by two forces. F1 is 8 Newton and F2 is 6 Newton. So their resultant force acts between these two forces. Let F be the resultant force, acts. And the resultant force F makes an angle theta with the force F1. The resultant force F acting on the body. Since there are two forces mutually perpendicular to each other, F1 and F2, there are two forces acting on the mass of a body, 5 kg. So their resultant must act between them, and we have supposed that the resultant force F makes an angle theta with the horizontal force F1, which is 8 Newton. So give the magnitude and direction of the acceleration of the body. Give the magnitude and direction of the acceleration of the body. Give the magnitude, find the magnitude and direction find the magnitude and direction of the acceleration acting on the body. So since these are the two forces, F1 and F2, so we calculate the resultant force. And resultant force is calculated by using the formula root over F1 square plus F2 square. Because this is F1, this is F2, then this will become F2 and this is F1. We can use Pythagoras theorem. Resultant force F equals to under root of F1 square plus F2 square. The value of F1 is 8 Newton. So 8 square and the value of F2 is 6 Newton. So 6 square. So 64 plus 36. That is root over 100. And F equals to 10 Newton. So 10 Newton is the resultant force. When the two forces F1 and F2 are perpendicular to each other. Now we find the acceleration. So acceleration A equals to F upon M. Force is 10. Mass is given 5 kg. So acceleration 2 meter per second square. So the acceleration, the magnitude of the acceleration is 2 meter per second square. And its direction is given by the direction of the force. Find the magnitude and direction of the acceleration. The direction of the acceleration will be same as the direction of the force. The direction in which the force will act, the acceleration, the direction of the acceleration will remain same. So we calculate in this triangle cos theta. So cos theta equals to base upon hypotenuse F1 by F. And the value of F1 is 8 and F we have calculated. The value of F is 10. So this is 4 by 5. The value of cos theta is equals to 4 by 5. And theta equals to cos inverse 4 by 5. And theta is the direction of the resultant force which makes with the horizontal. So this is cos inverse 4 by 5. This is the direction. Because the value of 4 by 5 in cos is not given. So the result, the direction is cos inverse 4 by 5. Now the next question, question number 5.8. Question number 5.8. The driver of a three-wheeler moving with a speed of 36 km per hour. The speed of three-wheeler is 36 km per hour. We can convert this kilometer per hour in meter per second. So 36 into 1000 divided by 60 into 60. 6 into 6, 36. So the speed initial velocity is 10 meter per second. This is the speed with which the three-wheeler is moving on a road. Sees a child. The driver of a three-wheeler moving with a speed of 36 km per hour means 10 meter per second. Sees a child standing in the middle of the road. There is a child standing in the middle of the road. And the driver of three-wheeler observes the child and brings his vehicle to rest in 4 seconds. Brings his vehicle to rest in 4 seconds. When the vehicle comes to rest, then its final velocity v is 0. And the time taken to comes to rest, time is 4 seconds. in 4 seconds or after 4 seconds the three-wheeler comes to rest. And when the three-wheeler comes to rest means its final velocity v is 0. So what is the average retarding force on the vehicle? What is the average retarding force on the vehicle? We have to calculate the retarding force on the vehicle. The force by which the three-wheeler stops, and that force is called retarding force. Average retarding force. Average retarding force on the vehicle. The mass of the three-wheeler is 400 kg and the mass of the driver is 65 kg. So total mass of driver and three-wheeler. Total mass 400 the mass of three-wheeler and 65 kg the mass of the driver. So total mass of three-wheeler and driver both is 400 and 65 kg. So we have to calculate the retarding force. So to calculate the retarding force we will have to find the acceleration first, and for finding the acceleration we use the formula v equals to u plus at. The value of v is 0 when the three-wheeler comes to rest. U is 10, acceleration we have to calculate, and time is given 4 seconds. So 4a equals to minus 10, and the value of a is minus 10 by 4, which is minus 2.5 meter per second square. The magnitude is not negative. The magnitude of the acceleration is always positive. So the magnitude of the acceleration is 2.5, and minus sign shows that the force acting is retarding because acceleration is retarding acceleration. And then we have to calculate the force acting. So the formula for force F equals to mass into acceleration. The total mass will be used 465 into 2.5. Minus sign only shows the direction, not the magnitude. So for finding the magnitude, we ignore the minus sign of acceleration. So its value is 1162.5. 1162.5 Newton. So the retarding force acts is 1162.5 Newton. This force acts on the three-wheeler when it stops in time 4 seconds. Now question number 5.9. And we have given a rocket with a lift of mass 20,000 kg. Mass of the rocket M is equals to 20,000 kg. Is blasted upwards with an initial acceleration of 5 meters per second square. Its acceleration A is given 5 meters per second square and the direction of acceleration is upward. So calculate the initial thrust. Thrust means force. Force of the blast. Initial thrust of the blast means we have to calculate thrust. Thrust means force which acts in upward direction. T we have to calculate. So equation of motion for the rocket. Equation of motion for the rocket. Equation of motion for the rocket. The direction of the blast is in upward direction. Therefore, T is greater and the weight acting downward, T minus mg, and the resultant force is given by m into A. The direction of the blast means direction of the acceleration is upward direction. So T is greater, mg will be less, and ma is the resultant force. And T equals to mg plus ma. From both the terms, m is taken common, so g plus a. The mass is given 20,000. And the value of g, which we take 9.8. And acceleration is 5 meters per second square. So 20,000 into 14.8. 20,000 into 14.8, and that is 296,000. 296,000 Newton, and which is also written as 2.96 into 10 raised to the power 5 Newton. So this is the thrust acting on the rocket when it is blast in upward direction.